Hello everyone. So today I'm making videos explaining some like homework question from the work problems, and I will work through some problem that is commonly asked on the Discord. So it's mainly on sector 6.3 and 6.4. So I will share my screen. So now you can see my screen, right? So the first question you're asking about like find the volume of the to find the volume bounded by the axis. So by the y-axis. So now we need to explain. So there are like two ways to do this problem. So this is gonna be cylindrical shells. And the volume can be expressed as, so here's like the volume of this solid can be obtained by b over a is 2 pi x, and is the area function. Was outer radius and inner radius, but don't care. So just the area function, and then dx. This is the volume. Now I'm gonna rewrite all the. Now we will rewrite the curve in terms of x because it's easier to integrate. So if we have is x squared plus this expression is going to be y minus 2 squared, and it's going to be y squared minus 4y, and then plus 4 is equal to 4. This would turn into the x squared plus y squared minus 4y. It is a 0 here. Well, in this case, it's like writing in terms of y is better. Just rewriting the function in terms of y variable is better because they have like a x squared and y squared, so we need to modify a bit. Function in this one going to be d is c. In this case, it's like equal to 4, and it's like a 2 and a there. So this is just like an ellipse. So this is an ellipse. So if you put this function as an ellipse, if you put x equal to a 0, then y it is 4 or is -2. So about the y-axis, so rotating this curve, so presume is from a 0 to 2, but for y it can be 4 and then a 0. So we computing the upper and lower bound of the integral. this is gonna be like a this. So gonna be x is gonna be a, a square root of 4y minus y squared. Is 4 or on the 4 by plugging actually if you do dx it is 0 and the 2. So the integral is of the volume can be expressed as is 4L. This is like the bound is and then 2 pi y. And then the AX is this mess. It is this radical is the area function. 4y minus y squared. Then dy. This is the integral. And then just do all the like the integration, and then just solve this integral here. And it concerns this problem. This problem is a big one. So I'm just gonna copy and paste this question into here. In this case, it's like the volume by shell is like it's just like a shape, the curving side of a shape. We rotating them by y-axis. So if we just draw this like a line, do an eraser. So we just draw the line here and just rotating, or like the region is bounded by the y-axis, just rotating the region, and we just and we have is and in this case we need to by the y-axis is everything the solid and it's r out, r in, and it's gonna be use the I think gonna use the washer method because they're like outer radius and inner radius. So we're gonna be finding what is r out and then what is r in. If there's like a radius thing, to use the washer method. This is just we expressed the inner radius is 2 is the inner, 2 is inner radius. And then outer radius is 3 is outer radius. Here's like the radius, and because this is like is in terms of y, and it's like x cubic over x fourth over the over 2 is going to be x is 2y over 1 and 1 to the fourth, and we rewrite the expression and we type y equals to x fourth over 2 as x equal to 2y over 1 over 4. And this is the integral using the dy washer. Set up the integral. Eight is upper bound and 0 is lower bound. The pi. And the area squared and the function in this case is we will get it's going to be z squared. Going to be z squared. This is going to be 2y to the 1/4 squared. Dy. So this is an integral. And by computing integral, this is like a maximum amount of water. And it's like, and this is like the sum of the like the inside. If you want to do the outside, it's gonna. And if you want to do like all the function of the outside, you need to do like another integral for the larger volume. Gonna be the outer shape. Set up another integral expressing the volume. Sorry, I was kind of messing like a Discord messages. So we just need to set up another volume to compute the area of the outer. So it is this question. Yep, it's the volume. And then subtracting the and then do some calculation. Then that's the answer. Okay, 6.4. In question number 5, it is the work problem. So this is like a leaky bucket. So if you have a leaky bucket problem, select the length and like the and now just to list. And the first step is to list all the information provided. So the height is 10 meters. And the weight of the bucket, 10 kilogram. And what we want, like the weight of the rope, bucket, rope is going to be 0.5. Don't forget the unit. And this is the mass of the rope. So like the mass of the weight of rope. So we have like the mass of the rope is equal to expression is like the height is like 0.5 times going to be 10 minus x. When we set up this, and then the water draining from 10 meters level, and the total weight of water, it is 30 kilogram of water is 30 kilograms. And you want just to compute the, all like the work done to pump all the waters. So the rate of the water draining, it is, we have 30 kilogram as 10 meters. It is 3 kilogram per meters. So if we time the mass of the water is, now we need to find the mass of the water. Now we can write a formula or expression computing the mass of water. So mass of water is equal to the rate of draining times the height is like mass of rope. It's going to be 3 multiply 10 minus x. It is 30 minus 3x. And the total, now I can compute the total mass. Now compute the total mass. So if the rate is like 0.5, so 0.5 times like 10 is a 5 minus 5 minus 0.5x. So this is a part of the mass. So 0.5 multiplied by 10 minus 10 minus x, then plus this like the bucket mass is gonna be 30 minus x and plus the and put bulk mass, it is 10. V gap gonna be 0.5. It's gonna be 535 minus 45 minus 1.5x. And if you multiply like the, and then multiply the density, which is gravity due to the Earth. So the whole volume is, so the work needed is this integral. Upper bound of 10 is upper bound. So 10 is the upper bound of the height. Because this time it's like you're doing the work pumping up, it's like the vertical is a vertical motion. If you drain water, it's like it's going vertical, so it's like in terms of y. So you need just to kind of, it's what is the lower bound of a y and what's the upper bound of y. So 10 is the upper bound. Of this expression, going to be 9.8 times 45 minus 1.5x dx. And this is the work needed for pumping out all the water. Okay, now let's move on to the next problem. As the it is number 3. I know this question is confusing, right? I'm gonna divide line, so we will make sure it is not mixing up the whole thing. Need to mix on the divide line. So this is gonna be like another kind of complicated questions. So now we have the force function. F of x equal to this expression. X squared. The pound. So so for part A is to find the total amount of work needed to raising the payload, raising the payload from the surface of the moon to an altitude, it's the height of r miles above the moon surface. So it's from x equal to r to 2r. So r, it is the constant because we're integrating with x. So r is just the height. There's no, and it's not a variable. It's just the upper bound and lower bound. This expression. See, move is r squared p is constant. Is r squared p is the constant. We just move them out. Well, need to change the. And then integration is, and then this integral, wow. And then this integral is going to be 2r over r is x to the power to -2 dx, and then do the integration is the work. And for the part B and C, you just need to change the bound of the integral. Just need to change the bound of the integral to this. If you want to do r, or do 2r, 3r's, or so whatever is. If you try to from surface level to r, then it's like a 0 here, and then it's just set up the integral and make sure it's like the density. And I would just also send a review sheet of on the work problem, so make sure there's more hint on how to set up different integrals. Thank you so much.